CES, the huge consumer electronics show in Vegas, is mind-blowing. Each year, the technology and products designed to fix, help, and augment humans in all kinds of astonishing ways take us closer and closer to 11. Artificial intelligence bots, fascinating display technologies, machine learning tools, autonomous vehicles, flying autonomous vehicles. But I was particularly curious to know more about some of the ingredients that make these things possible. How amazing technology happens at a molecular level. This is why it was fortuitous that I attended CES this year as a sponsor of EMD Performance Materials Corp. EMD is a business of Merck KGaA Darmstadt, Germany. As part of Merck KGaA Darmstadt, Germany's Always Curious initiative, they have led the charge researching the role of curiosity in the workplace. Among EMD's many innovative technologies are the ingredients they provide to the semiconductor industry, ingredients that are necessary to create the very products that will advance our human performance in ways we have yet to dream of. How does EMD do it? In the case of directed self-assembly technology, they get molecules to do their bidding. And this provides a solution that enables chip scaling, like 3D NAND. 3D NAND is a type of memory chip where memory cells are stacked in multiple layers, 3D. Why should you care? This is the technology that will give us products that have more reliable storage in smaller form factors. Smart products with incredible abilities, products that are faster, smaller, and more cost-effective. Curious questions can always be relied upon to turn complex and complicated into understandable, and it's often made easier by a trip to the bar. Directed self-assembly technology was no different. I'm here with this team from EMD Performance Materials, a division of Merck KGaA Darmstadt, Germany. And we are going to be describing how this company has molecules do their bidding. Okay? So I asked Dong. Dong, introduce yourself.
Nice to meet you. I'm leading our packaging business field in semiconductor solutions. And I used to be the first program manager for this, our beautiful, innovative technology, the directed self-assembly. So I wanted to explain how it works and how we do it.
Fantastic. So there's directed self-assembly, and from what I understand, today, using our favorite brown beverages, we are going to be demonstrating the SA, the self-assembly part of the directed self-assembly. Is that right?
Right.
So now we have Andreas, Chief Bottle Opener, and introduce yourself.
If I'm not opening bottles, I'm responsible for external communications of performance materials.
I think those are beautiful, a beautiful marriage of skills. So show us what you got.
So which one should I open now?
Actually, order doesn't matter because this is self-assembly.
Whoa!
Ooh, yeah.
He learned something in college. Fantastic. So self-assembly, black and tan, order doesn't matter.
Right.
Okay?
And we need to open this one also.
This one as well. Now it's getting difficult, but I luckily have another bottle.
What?
Oh, wow.
Whoa. Smooth. Okay, let's see it happen.
Okay. Let's see. Basically, we try to make black and tan, the famous beer. We need to wait. The foam goes away.
I think that if I've ever tried this experiment before, I might not have been patient enough not to drink it and letting the chemical reaction take place. But today, today my curiosity is winning out over my love of brown beverages.
Let's say this is our DSA product. When we send it to customer, this is what they see, all mixed material. And now, put it away, then it will do self-assembly by itself, by the separation of those two different materials.
So while we're waiting for the self-assembly, maybe you could spend a minute describing what the directed self-assembly part of your technology does while we wait patiently for the self-assembly to happen.
So actually for the semiconductor industry, there are a lot of different patterning technology, and they try to use the forced exposure method to make the pattern on the silicon wafer, but our self-assembly material doesn't require those special tool set because it does patterning by itself. So that's the beauty of our technology for direct self-assembly.
And what kind of use, how does this translate into products? What kind of products does this turn into?
So in the end, everything goes into our gallon bottle, the chemical material, and it goes to customer, and then they use it to coat the wafer, and then it makes the smaller feature sizes pattern.
So far, I don't feel that they're doing your bidding. I don't feel that the molecules are really doing what you're telling them to do. Maybe you need to.
We need some process. Yeah. Maybe I should drink.
Yeah. I think maybe you should have a little. Well, let's wait and see. Actually, does it taste different? Does it taste different when it's blended like this?
Mm-hmm. Right.
Which do you prefer, the self-assembled black and tan or the mixed black and tan?
Actually, I'm a big fan of black and tan because you can taste two different things, and you can drink away the first one, and then you can taste another one in the end. So that's actually the theory of self-assembly. Two different materials. You want to take out one thing, and then the other part remains on the wafer. That gives you the final pattern.
Ooh, fantastic!
Right.
It's starting.
Starting.
About how long does this process take, Dom?
Our brown drink experiment using Stella Artois and Guinness Stout beers didn't quite work as planned. A few hours later, after convening to the nearest bar for additional research, James Haley, EMD's VP of Marketing and Sales, and Dong Lee, Global Marketing Director, returned with the mystery solved.
So I asked the gals who said, hey, can you make a black and tan? She says, no, I'm sorry. She goes, no, we don't have bass. We need bass ale to. I said, we had a customer last night that came in and really wanted a black and tan. We tried it. And we had the Guinness. She says, we have the Guinness. And we use Stella. And Stella won't work.
Wait, are you telling me that if we had had Bass instead of Stella, it would have worked?
Exactly.
So we don't have the right raw material for the recipe. Right. So even measuring wasn't going to help us. Right.
Okay, so you never said that self-assembly was raw material specific. That's one of the most important things.
Measurement, environment, proper glass, maybe. We don't know.
Explain.
So it shows the meaning of Kai, which means the separation, phase separation ability, affinity or the other way, between these two raw materials. So it means Guinness and Stella has low Kai, which means mix up together and doesn't separate easily. And Guinness and Bass has very high Kai, so that they can be easily separated, gives clear the end line of the pattern. So it means for smaller feature sizes, higher technology. So that's the.
So that allows the separation in color between black and tan.
Right. So we do need to find high Kai beer.
My favorite experiments are the kind of experiments that require a bartender.
Yes.
And
they know.
We answered. CES is successful.
We will try again. We will do another one.
We'll do it. We're coming back.
Make it right.
You know what? That is taking one for the giver.
We were frustrated.
Perfect. Now we know.
Now we know why.
Thank you.